Hello students, welcome back. Let's conclude section 4. We got this. With a lot of difficulty, we got this. So let's use it. We went through one problem here already. And here is another problem. Oh, this is a problem we already discussed. We are supposed to get sine of t, cosine of t, cosine of t, sine of t, negative sine of t, cosine of t. Yes, this is the same problem that we discussed earlier. Where is it? Where is it? Right here. And over there, we just calculated a to the k power t to the k power, put everything into the definition, and then simply hoped for the best to find out any pattern. But this time, let's do something more clever. This time, let's find out the resolvent matrix. Si minus A is okay, this is I, so 1, 0, 0, 1, and then minus A, so that's what it is. And then S times this, so let's do this. And therefore, S minus 0, so that's S minus 1, so S minus 1, and then 0 minus of negative 1, so that's positive, and S minus 0, we have S. Looks like that's the matrix we have here. And then the resolvent matrix, Si minus A inverse is, well, we'll have to use the inverse matrix formula. 1 over AD minus BC, so S squared AD minus 1 times S minus 1. And then we have to switch the principal diagonal and then put negative of the other diagonal. Let's finish this computation. S squared minus S, we have 1 over S squared minus S plus 1, isn't it? Okay, and then that. So I guess I can divide this one by S squared minus S plus 1. And this one like that. And then this one like that. And this two like that. Okay, that's the resolvent matrix. Now, find the matrix exponential, so I have to take the Laplace inversion. How do I take Laplace inversion from here? And let's see. The denominator is prime, so I cannot factor it, so I'm going to get sine cosine. Oh, excuse me, did I make a mistake? Oh, this is not S minus 1 over here. This is wrong. I made a mistake here. S minus 0, 0 minus negative 1, so this should be just minus 1. Let me correct this. So that's just that. And then here, crisscross, S squared plus 1. So the denominator is a whole lot simpler. and then this one is just 1, and that's minus 1. Okay, all good, as we have over here. And then taking a Laplace inversion, we get this, and this one follows immediately from that Laplace table in page 123. We have S here, and then A value is 1, so we have cosine of t, and then here no S, just constant, and then B value is 1. This is just a sign, and this is negative sign. They come directly from that page 123 Laplace table. Okay, how about the next problem here? 1111. I thought I selected this problem here. Did I make a typo and then got 1 instead of 0, or is this right? I don't know, I'm not so sure. Let's just suppose this is correct problem, and then let's just find out resolvent matrix Si minus A. So S times I is 1, 0, 0, 1. So this whole thing can be rewritten as S like that. And therefore, if I subtract, this is going to be S minus 1, and then 0 minus 1, 0 minus 1, and this is going to be S minus 1. Actually, many students go from here to there directly. You see, all these become negatives, and then on the principal diagonal we have S. So that's about it. Okay, now that we have Si minus A, let's calculate Si minus A inverse. Okay, again, please recall the inverse matrix formula, AD minus BC. So multiply the determinant, AD, multiply the principal diagonal, BC, minus 1, minus 1. So we get that. And then as for the matrix, we have to switch the principal diagonal, S minus 1, S minus 1, but no change there because they're the same. And we have to take the negative of the other diagonal, and here we go. And let's see, this one is 1 over S squared minus 2S plus 1 and minus 1. So these will just disappear. And then this is a matrix. So this one divided by S minus 2. Did I do this right? And then this one, S minus 2, and S minus 1, and divided by, come on, S minus 2. And then we can work out the decomposition by partial fraction. Well, you can work it out. You have factored form here, so you can set up appropriate systems of linear equations and so on, but it's just too tedious, so okay, all right. Yeah, okay, I see. Please ignore what I have in the solution. I did a problem with this 0 here, so let's just do this problem. And then let's work out this. And oh boy, all right. What choice do I have? Apart. This one. And then that is the partial fraction. So and then this one can be rewritten as 1 over 2s plus 1 over 2s minus 2, I guess. That's it, isn't it? We got 1. And then how about the next one? We get 1 over 2s, but negative of that, plus 1 over 2s minus 2. Okay, the difference is this becoming negative. And then same thing here, so let me copy and paste this thing down here. And then this one is same as the first, so s minus 1. Yeah, this. So if I take the Laplace inversion of this, what did I click? Sorry about that. I don't need this partial fraction computation anymore. That is equal to the Laplace inversion of this. And then let's see, what is this? Let's see. Okay, the first one, 1 over 2, and then Laplace inversion of 1 over s is t. 1 over 2, the Laplace inversion of 1 over s minus 2 is e to the 2t power. Next, the Laplace inversion of 1 over negative 2s is negative 1/2. And then the Laplace inversion of 1 over s, that's going to be t, plus this one, 1/2 e to the 2t power. How about this one? Actually the same thing, so I can just copy and paste this one here. Same thing, so I can copy the pasting here. And that is the matrix exponential that I want. Okay, let me copy and paste these solutions here. And we got these. And then find the matrix exponential. And then let's copy and paste this part over there. And okay, there you go. And then put everything together. Okay, there you go. There's the full solution there. So from here, we can take the resolvent matrix Si minus A and do your computation here, and then take the inverse matrix using the inverse matrix formula, AD minus BC, 1 over AD minus BC, crisscross, and then switch the principal diagonal and then put negatives there, which I did over, okay, correctly done. And then decomposition by partial fraction, and this can be really tedious, so as you witnessed, I used mathematical command apart for that. A bit of cheating maybe. And then using these, and then you can go back to this Laplace table and then get all these done. So e to the at power turned out to be this. Okay, that was for this problem. And now let me erase these. As I suspected before, this was a typo actually. And the solution here I wrote down here about this matrix. And that's the matrix we studied before here. This one. We have a little bit of time, so let's study this. So Si minus A, how does it work? Si minus A, here's a computation. S00S minus this, and here, okay, I just plus and then take all those minus signs and then did a computation there. Well, that's equivalent. Yeah, S minus 1, minus 1, 0, S minus 1, okay. And then we can use the inverse matrix formula, crisscross, multiply the principal diagonal, AD, minus BC, but minus BC, that's 0, so that's when it's killed. So I have S minus 1, total quantity squared, and then switch the principal diagonal, no change there because they're the same, and take the minus of the other diagonal. This minus made this plus, and 0, no change there. And slipping in this denominator, we get this expression here. 1 over S minus 1, 1 over S minus 1, and 1 over S minus 1 total quantity squared. Now, from here, let's take the Laplace inversion. The Laplace inversion of 1 over S minus 1, e to the t power. And this one, same thing, squared. So t e to the t power. And then we have e to the t power like that. Again, you can look up all these from Laplace table. And this is a solution for the last problem. And inadvertently, I made a typo here in the previous problem. And then I ended up with creating another problem. But luckily, that problem turned out to be okay too. So I did it. And this is a problem actually I prepared. And then here's the full solution. Again, the decomposition by partial fraction is something I do not really want to deal with in paper and pencil computation. So I relied upon computer for that. Otherwise, all good. And so much for section 4.